back to my fourth live streamings or vlogs. So let's proceed to another topic. Actually, this is not a new topic, guys. Okay, this is in conjunction to my previous topics that I want to intensify and expand more. This time is going to be comprehensive. I have to list all the atomic masses and atomic weights. Okay, so it's going to be like that. Okay, so this is very useful in having stoichiometric relationships and solving different problems, chemical calculations. Could it be, shall we say, in thermodynamics and physical chemistry, in stoichiometry, what else? Or a little bit of, shall we say, unit operations in the higher chemical engineering, subjects in the entire curriculum of Bachelor of Science in Chemical Engineering. Oh my gosh! So, where's my microphone? Oh, I love to use the microphone. Where is that? Oh, it's here. So I'm full now. So what's my dinner for today? Wow. Okay. Hello, mga palangga kong kita. Okay, my dinner for today is only Korean noodles. Wow.
The Bluetooth device is ready to pair.
So I love Korean noodles. That's only my dinner for tonight. And plus water. Okay? Nothing else. No meat, no sugar, and everything. Only noodles, Korean noodles. And water. Okay. So I'm full now. So it's good to vlog once again, right? Okay, it's gonna be like this. How can I start with this vlogging? Okay. So it's gonna be like that. To give you a summary of the periodic table, I have to show once again. Okay, it's gonna be like 18 columns. Okay, 1, 2, 1, 2, ganon, diba? Okay, like this. Okay, so like this, ganon, like this also. Okay, ganon. Okay, and then we have here, okay, mga palangga. Then we have here, like this. Okay, ganon. Okay, so 18, right? So how can we do this? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oh my gosh, okay, 11, okay, 12, 13, 14, 15, 16, 17, 18, right? Okay, it's gonna be like that, and you have to connect this from here, put an imaginary line to ganon. Okay, like this, okay? Ganon, ganon. And then, like this. And then you have to connect this here, from here to here, like that, and then this one also here, imaginary line, and then like that, okay. Then it's gonna be like that, and then ganon. So, ganon siya. Okay, so 4, 1, 2, 3, 4, it's ganon like this. Okay, mga palangga. Okay, it's gonna be like that. Okay, so 18 columns, right? Something like that. Okay, like this. Okay, I'm not good in drawing. Okay, so we're gonna be doing this one. 7 already siya, guys. 1, 2, 3, 4, 5, 6, 7. Okay, ganon. 7, and I have to erase this one. 7 naman na siya, mga palangga. Okay, like this, ganon. Okay, 1, 2, 3, 4, 5, like this. Okay, like this. Okay, 1, 2, 3, ganon. Up to here, ganon. So it's gonna be like that, right? And then 1, 2, 3, 4. So 1, 2, 3, like this. Connect. Okay, connect. Okay, connect. And then here we need to erase this one. Okay, something like that. My purpose is only to make it straight. Right, mga palangga? Okay, ganon. This is gonna be like ganon. Okay, it's gonna be like that. Okay, so we'll start with group, capital G is 1A. Group 2B, and then we have also here, let's connect this continuously here, like that. Okay. Ganon. So, from here to here, mga palangga, it's gonna be transition metals is here, or transition elements. Transition elements, mga palangga. Okay. Can you see the board? Oh, wow! I have a very beautiful periodic table. Wow. Nakaloka. Okay. So, it's gonna be 1B, 2B, ganon-ganon. Diba? 1B, 2B, ganon-ganon. So, 1B, kung kita guys, 1B, 2B. Okay, ganon-ganon. Okay, and then we're gonna start here, 3B. Okay. So, I will use Roman numeral instead of, what is this one, huh? Roman numeral lang tayo. Okay, 1B, 2B. Because it's being used in the periodic table are Roman numerals, right? Okay, 1B, 2B, 3B, and then it's gonna be 4B, like here, 5B, and 6B, like that, 7B, oh my gosh, 7B, kaloka, 8B, and then 8B. There are 3 8Bs mga palangga, take note, okay? And 8Bs also, ganon, okay? So here, 1, 2, 3 are all 8Bs. Here, like this. Okay, so this will be our identification. You get the point? And then, ganun siya mangyayari, mga palangga. Then you have to say like this, ganon. And then we have here. So, in your 4B, you have to attach here, straight, like this, until here. Until the last column, 18. So you will start 4B. Oh, ganon. So like this, di ba? I'm not good in drawing, okay, but you know, kalau isa Ginoo, my engineering drawing is, I think it's only 4.2, okay? Because in CIT we have highest number of the academic grade is 5. The same as, I think this Ateneo, I don't think, LaSalle or Ateneo. 5 is our highest and our lowest is 1. Okay? I don't think so. It's gonna be LaSalle. I'm not sure. Okay? So, in the Philippines, only 2 schools have the highest grade of 5. Our school and the other one in Manila. Okay? So, our 5 is 100%. Okay? Our 1 is 75%, so lowest. Something like that. Okay? As far as I could remember, engineering drawing subject, that's not academic, right? It's only 4.2. It's gonna be that range 4 plus, but it's not really that high, okay? I'm not good in drawing, right? Okay, so this is lanthanide. Okay, lanthanide series. Okay, here. Okay? Guys, by the way, lanthanide is also known as lanthanide. It's just the same, huh? Don't be confused. So, lanthanide and lanthanide is just the same. Other references put that as lanthanide. And most common is lanthanide. It's just the same. Only the letter A changed to O it's the same. Okay? And then the other one also will be the actinide series, the last here. Okay? O, diba? Connect. Taradat. 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 Ganon. Okay, ganon, connect. So, like this. There's no like this in our examination in the future. This is only for the purpose of discussion, to make it easier, because I cannot present to you the periodic table. Okay? So that's why I memorized. Okay, like that. Okay, and we have the actinide series here. Okay, mga palangga. Okay. So the actinide series will be the atomic number is gonna be 90 to 103, but let's check. We'll start with 1. 1, left to right, 2, okay, 3, 4, 5. Increasing atomic number as far as Nepomuceno the leaf discovered the periodic table. Increasing atomic number. So 5, 6, 7, 8, 9. Oh my gosh, too long. 10, 11, 12, 13, 14, 15, 16, nakakalo pa. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, oh, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 100, 101, 102. Oh my gosh! Perfect! When was the last time I count from 1 to 100? When I was in elementary. Because it's in there, at that time, we count a lot in our elementary grade school level. Grade 1, grade 2, grade 3, grade 4, grade 5, and grade 6. So counting like that, okay? Now, I'm coming back counting. Imagine from 1 to 101. Okay? So I could say for the very first time. Okay. Like that. Okay? So nobody dares to count from 1 to 101. Only me. Okay. So it's gonna be like that. So I want to be unique. Okay, I'm counting from 1 to 101. So this is gonna be the atomic numbers of the elements. Okay? So these atomic numbers, as you can see, increasing, right? And at the same time, from the top to the bottom, in the group is also increasing. See? 1, 3, 10, 17, 34, 51, 68. Here, example, the noble gas. See, 2, 9, 16, 33, 50. Increasing atomic number, and also left to right. Okay, also in the actinide, see, 19, 81. Increasing from left to right. Okay? Something like that. Now we will continue this one. This is 3A. Okay, group 3A. This one. Okay, group 3A, group 3A, 4A, 5A, 6A. Ganon. So this grouping, guys, from here, group 3A to group, this is 7, right? Okay, 7 or 7A? I think 8A, or blah blah blah, so and so. Okay, okay, like this. It's gonna be like Periodc. Okay? Ganon, ganon, ganon. So, napatay 7A. Because what I memorized, there's a group 8A. So, we have locked one of column. So, the group 8A and the group 0 is the noble gas. That's why I add one column. Okay? Like that. So, group 7A, then group 8A. Group 8A is also called group 0. Okay? Like that. So, my atomic numbers now will be coming wrong. So, I will adjust this. Very easy to adjust, right? Put the 20 here. Okay? 19, 20, blah, 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 so and so, right? Okay. So, you will adjust. Put them here, and everything will follow. It's easy to count. It's not an issue, right? You have to adjust only. So, 5, 6, 7, 8, 10, and fill up it once again, like that. I have to count again. I'm tired. Okay? Something like that. So, for the purpose of discussion only. Okay? So, ganon. Okay, what you will do for this? So, group 1A. Ang sama na sa group 1A. So, blandayin mo siya. Okay, hydrogen, lithium, sodium, potassium. Ganon, di ba? And then we have rubidium, cesium, and francium. Like that. Okay, and then for the second group, we have the beryllium, magnesium, calcium, like that. We have also the strontium, barium, and the radium. So these have two positive 2 charge. Okay, the group 1A positive 1 charge, or can be stated differently, have 2 valence electrons in the outermost shell for all group 2B, and 1 valence electron of all group 1A. Ganon, right? So for example, if the atomic number of, let's say, beryllium is 4, like this, okay? Our electrons is 4 like this, okay, ba? So how can we do the electronic configuration for that? So we will start here. I will put here a little bit of explanation at the bottom so that we can make the electronic configuration, okay? Like that. Okay, now I have here 1s, 2s, 3s, 4s, then 2p, 3p, 4p, and then 3d, 4d, and then 4f. So SPDF orbitals or subshells, right? So you will like this, tararat ganon, tararat ganon, tararat ganon, tararat ganon, tararat ganon, tararat ganon. It's gonna be 1s2 for the, let's say, beryllium, 4 atomic numbers for so. 1s2, then 2s2, perfect. Okay, so 2 plus 2 is equals to 4 electrons of beryllium. So this is beryllium. Say beryllium with atomic number of 4, ganon. So this is in the second energy level. Ganon. So that is 2. See? The beryllium is in the second energy level. 1, 2. The row 2, meaning this is in the second energy level. You get the point, mga palangga? So, there are 2 electrons in the second level. So if you try to draw the beryllium like that, so 1, first circle, second circle. In the second energy level is the second row, so we have 2 electrons. We have 2 electrons here in the outermost shell here. See? Like that. So 1 electron, 2 electrons in the second most energy level outer shell. So n is equals to 1, then n is equals to 2. So this n energy level represents the outermost shell and represents also the period in the periodic table here in the family. Okay? Get the point? Muna siya mga palangga. Okay. So, beryllium have 4 electrons. We have 1s2, 2s2, 2, like that. Now you will say, oh my gosh, n is 2, o ganon. So, n is 2. Ganon sa imo. So, we have s, p, d, f. Since that is 2s, meaning s orbital, suborbital. Oh, s mga palangga. So, it's s. How can we compute the orbital? How many orbitals in s sublevel? So, how can we compute for that? So, we need to have the, you will to memorize this formula, n times l plus 1. Okay, ganon. So S, P, D, F. You are not concentrating with PDF. We have S only. We are focused because the last, okay, sub-level here is S for beryllium. Okay, now, 2N. How much is the N here? Like that. So we have 2, right? 2, ganon. Times, how much is our L? Like that, so it's gonna be L. Okay, 0, ganon. 1, okay, we have 2, 3, ganon. So 1, 2, 3, 4. Oh. So our L is 0 for S. Okay, ganon. So L, substitute here, 2 times L 0 plus 1. So 0 plus 1, there is only one orbital in S. Okay? In S subshell or sublevel, there is only one orbital. Okay. Now, this orbital is your identification that there are 2 electrons will occupy every time in that orbital. So how can we show that here? So it's gonna be like this. Let's say I will put the orbital as square for the purpose of discussion only. Or you can have circle, whatever shape you want for the purpose of discussion. Let's say one orbital square, one orbital like this. So how can we fill these 2 electrons? We need to follow the theory of Pauli's exclusion principle. Okay, that every orbital should occupy two electrons in an opposite spin. Meaning to say, opposite spin, the positive one half and the negative one half. And do not fill directly each orbital. Go first all orbital and then come back. Okay, now here we have the two, right? Two electrons. So perfect. Okay, because there's only one orbital, and you will say like this. First is going up, second is going down. So there are two electrons in this orbital, right? So the last arrow, that is your basis for your magnetic quantum electron spin. Ganon. Or electron spin quantum number, the abbreviation or the symbol is ms. So your ms here is, since going down, it's going to be negative 1/2. Okay, like that. So how can you determine your ML, your azimuthal quantum number, or what we call the determination of the shape of an atomic orbital? Okay, so this is responsible for the shape of the orbital. So it's gonna be, what's this? You get to determine your ML, magnetic quantum number, how much? So your magnetic quantum number, guys, this is 1, right? And then you say, here, n is equals to 0, okay, 1 or 2, then L is equals to 0, like that, then 1, 2, 3, and then you have the S here, right? S, orbital is 1, right? Use this one box, 1 orbital, and then 0 here. So 0 only, so only 0 here, no need, only 0 here, because only 1, right? Okay, only 0 your shape of your orbital, only 0, so nothing else. So you will say ML is also 0. Okay, your magnetic quantum number 0, as electron spin, magnetic quantum number electron spin is negative 1/2, and N energy level is 2. Okay, sub level is S orbital. Okay, S orbital like this. Tigat mga palangga. And your azimuthal L is 0. Azimuthal mo siyang L, guys. Okay, azimuthal. So L. Okay, so 0 yung L. Okay, 0. Ganon. You get the point. Okay, like that. So it's gonna be like 0 ML, 0 L, and so 2 MS, so negative 1 na. Because only 1 lang would siya. Then, for example, if this is 2, also let us 2, okay, and then 0, negative 2, negative 1, and positive 1, positive 2. So there are 1, 2, 3, 4, 5. There are 5 orbitals. If your L is equal to 2, here, right? But here L is equal to 0. There is 1 orbital only. That's why you stop to the 0 also. Okay, you get the point. So it takes a lot of better understanding to understand the electronic configuration, because there's a lot of confusion somewhere along the way. Okay? And you know, you have to make extra effort to understand this. Okay? Ganan. Okay. Now, since we fill up the energy level based on the lowest energy level, say 1, 2, 3. So these rows or periods are following also to the Offbow Principle. Okay? In electronic configuration, meaning to say each orbital must be filled first with lowest energy before going to the highest energy level. It will start really from the lowest then to the start. So that's principle or theory comes from Offbow Principle. Okay? So we learned the Offbow Principle, we learned the Pauli exclusion principle here. Okay? And we learned the Dimitri Mendeleev here also. Discover the periodic table. Okay. Now there are 3 laws involved here also. I must erase this now. Nobody dares to make this, right? Okay. I think only me. Charot! Only me, because it is manual. Others, I think in YouTube, they are doing the, you know, the digital, or, you know, by having the PowerPoint and everything. But me is manual, writing only. I think I am the only one who do this all over the world. Okay, by doing by hand. Okay, so I think they discuss it, but more on the PowerPoint, in the Excel, in their videos, but me, hand talaga siya. Okay, Isuwat yun ako sa kong kamot. Okay. Like that. The periodic tables, 118 elements. Okay, ganon. So now, we'll go back here to the important K personnel. Wow, important K personnel. Just like in every department, there's a K personnel or K staff. So, in terms of the K personnel are the following. Okay. Antoine Lavoisier. Wow, Antoine. I think he is French chemist, French or German. I forgot. Okay, Antoine Lavoisier. Okay, like this. The spelling is very, very difficult for the Lavoisier. Okay, so he is the father of modern chemistry. Okay, father of modern chemistry. Okay. So without Antoine Lavoisier, so we don't understand really the elements around us, the water, the air, the oxygen, the carbon, whatever. Okay? The nitrogen and everything. Okay? Like that. So mapasalamatan ni Antoine Lavoisier. Okay. Number 2, we have the law of conservation of matter. Wow. Okay, law of conservation of matter. Okay? So this is under the name again by Antoine Lavoisier. Okay, like this. So you have your blank sheet of paper. Or anyway, you can refer to different books, right? It's just the same. Okay, so it states there that matter, okay, matter can neither be created, okay, by your hand. Okay, matter can never be created nor can be destroyed. Okay, nor can be destroyed by ordinary chemical means. Okay, so what does it mean? Meaning to say you have to apply the different operating condition or chemical reactions in order the matter to be changed from liquid to solid to liquid to gas. Okay, but you cannot never do that by only manual without the temperature, pressure, catalyst, like that, changing the volume, whatever. Okay, so that is what it means here. Matter can neither be created nor can be destroyed by ordinary chemical means. So the most example to this, guys, is really burning, okay, pyrolysis, okay, pyrolysis of pyrophoric substances, okay, pyrophoric substances, meaning substances that are highly flammable and explosive. Okay, those are pyrophoric substances. Higher flammability, at the same time, higher explosivity or explosive rating. So it's totally different if it's high only in flammability, that's only flammable. It's only different also in saying higher in explosion rate, it's only explosive. But both, if you say pyrophoric substances, flammability and also the explosion rate or the explosivity. You get the point? Something like that. So the identification of the flammability is our flash point, and the indication of our explosivity is the lower explosive limits or LEL. Okay? So we can measure that if we have the gas testing device or any environmental monitoring device. Okay? To test really the different substances, liquids, solvents, or whatever. Okay? So this is pyrophoric substances. So pyrolysis, burning, what else? A lot, guys, huh? We have also decomposition reaction, ganon, combustion. So that's what it means by ordinary, not by ordinary chemical means. Okay? So the matter, which is the liquid, solid, and the gas. Again, law of conservation of matter says matter can neither be created nor can be destroyed by ordinary chemical means. Like that. Okay? You got the point. That's it. Okay, number 3, we have the law of conservation of energy. Ganon. Law of conservation of energy. What's this all about? Okay. So this means the same pattern, but you need to understand that it's talking about energy already. So it's gonna be like this. Energy, okay? Change only the matter into energies so that for your memorization, it's easy for you to troubleshoot. Okay? So energy can neither be created, the same story, only changing the noun. created nor can be destroyed. And then you will stop here. You will change the words here. After the destroyed, you will change like this. Energy can neither be created nor can be destroyed, but you will put but, meaning a conjunction. But and while, like that. Those are conjunctions in English, right? But it can be transformed, okay, transformed into various forms of energies. Okay, various forms of energies like that. Okay, so for example, if you start with PE, potential energy converted to kinetic energy, and then to chemical energy, then go to, let's say, electrical energy, then go to, let's say, light energy, okay, sound energy or acoustic energy, and then pneumatic energy, hydraulic energy, radiation energy, so many energies around us. Okay, like that. Get the point? So these are all energies. And the most popular are the kinetic energy and the potential energy. Okay, mga palanggan yun also activation energy. Activation. Okay, before achieving the maximum kinetic energy of different substances, especially in the kinetic molecular theory of ideal gas, we need also to discover the activation energy. This is the lowest point of energy in which the chemical reaction will proceed or will start. You will achieve the minimum lowest activation energy before starting to have your products or your chemical reaction to proceed. So this is activation energy. Okay, minimum energy din siya guys ha. Minimum energy needed, okay, to start the chemical reaction. Minimum energy needed to start the chemical reaction. So this is also another definition. Okay? So, maghinahinin na pag-memorize. Well, while ago, I have the meaning of ionization energy, electron affinity, or electronegativity, electropositivity, then activation energy, and all of these energies, okay? But some energies are easy to understand, no need to memorize. Okay? By having only the formula, then bingo, you can, that's the meaning of that. Through the formula, you can understand. So, for example, nothing is total energy. For example, I have example only, guys. Then since heating is the most common example in chemistry, heating, applying, raising and lowering the temperature is the most common example in chemical reactions or in chemistry because temperature is the most influential operating condition of all the physical properties. Okay? For example, temperature, pressure, volume, amount of the substance, the mass, the boiling point, the freezing point, the melting point, something of all the properties, this temperature has the highest influence to change or to proceed your chemical reactions. The alteration of one phase or form to another. It's really temperature, guys. It's not the other. There's also pressure, volume, nature of solute and solvent, catalyst. Okay, catalyst, the inhibitor, something like that. You get the point, but really temperature is the most influential operating condition that will change the chemical reaction, proceed the chemical reaction, blah, 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 like that. Okay, muna siya yung may tabo, guys. So, since I'm talking about the temperature, then I must relate that with heat. Okay, because the heat is measured by temperature. Okay, temperature changes or temperature gradients from hot to cold or from, hot to cold. Okay, you get the point. Okay, maybe to say from higher temperature to lower temperature. Okay, something like that. So heat o ganon. Ano siya. So heat, so I have heat. Okay, chuba-chuchu. Most popular is Q is equals to mCp dt. Gas. Okay, mo yung may gamiton. Okay. And you can change that to Q is equals to MC delta T. Okay, just to avoid the CP thing. Because CP, there's a lot of meaning. It could be a computer, it could be a cell phone. So I like to use the C only. Stands for specific heat capacity. Get the point? Okay, but this MCPDT is really widely used. Okay, but it depends on as long as you understand. It doesn't matter what letters you use, right? Okay, like that. Okay, and this kind of heat, guys, Q is equal to mCp delta T or mc delta T based on temperature changes. Okay, like that. Based on temperature changes. And then based on phase changes, the another formula of heat will vary. What are those? For example, heat of condensation, heat of sublimation, heat of vaporization or vaporization, heat of deposition, like this, heat of condensation, like that, blah, 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 so on. So the phase changes. Okay? So you will use this delta H is equals to N times HV, like that. H is equals to M times HV. Why I use N and N? Because sometimes, guys, your heat of vaporization is expressed in calorie per mole Celsius. That's why N, HV. Sometimes also the HV is represented in calorie per gram degrees Celsius. That's why N will be the partner of HV. The purpose is to easily cancel. And what will left is your calorie or the joules or the British thermal unit or any kinds of unit in energy after you cancels out. There's, coefficient here, the mass and the number of moles. But this V, capital H are different phase changes, starting evaporation, condensation, sublimation, like this. Only put capital H. And mostly these guys are standards already. Okay? Then you have to multiply that, then you have the heat. Okay? Do not apply the phase changes, computation of heat, to the temperature changes. This is another story, and it's obvious in the problems also. Not sometimes, all the time. Very obvious. For example, you have to heat the ice to steam. So there's a lot of processes before it will go to steam. Okay, from solid to liquid, from liquid to gas, and like this. So many changes will be happening there. There's a temperature changes, there's a phase changes, and you have to apply this also. And you apply also the Q is equal to mCp until such time you will determine the steam. Okay, you superheat the liquid into steam originally from ice. Okay, something like so. These are the examples for the heat ganon. So, muna siya nagtabo mga palangga. Okay? Now, so atong ko lang katong mga specific heat capacity, molar heat capacity. Okay? So, marami siyang versions. Okay? So, heat capacity is another story. Okay? And then, specific heat capacity is also another story. This is not one. Be careful, okay? Like this is heat capacity, specific heat capacity, okay, and the molar heat capacity is not the same. You can determine this through their unit. Heat capacity is calorie per temperature lang siya, degree Celsius baron, o calorie per degree Celsius. And the specific capacity is calorie per gram degree Celsius. Okay. And the molar heat capacity, calorie per mole degree Celsius. Your identification is molar, so there's mole in the denominator. Specific, there's gram in the denominator. So the word specific, guys, indicate the mass. Okay? Not only this, also in the steam table. If you encounter solving the unit operations in the steam table graph, there's a lot of specific chuba-chucho. For example, specific entropy, specific enthalpy, specific internal energy, specific volume. Okay, and then you have to adjust your formula. Okay, for example, specific volume. Guys, specific volume, that is also the reverse of density. Okay, so specific volume. So you need to say volume is cubic meter at the top. And then, since I told you that the specific have a gram or any kind of units at the denominator, it will become cubic meter per gram or kilogram. So if you reverse this one into kilogram per cubic meter, this is also density. Now, if the question in the future will say, blank is the reverse of molar density, like that. Okay? The reverse of density. Your answer will be specific mass. Di ba nakakaloka? O di ba? Okay. Because the density is the reverse of your specific mass. So therefore, we conclude specific mass, molar mass, and the mass regular are not the same. Again, okay? So that to avoid confusion. Specific mass, okay? Specific mass, molar mass, and the mass only are not the same. Okay, if the given in the problem is specific mass, okay, mga palangga, there's always grams in the denominator. Okay, you get the point? Ganon. And then if it is a molar mass, of course, there's a mole in the denominator. That is the molecular weight. Right? So the reverse of the density is your specific mass. Okay? Like that. That's why, for example, specific volume, cubic meter, gram. Kailangan tayo specific. So density niya gram over cubic meter. Okay? So, specific volume. Okay? There's also specific volume, specific mass, specific enthalpy, specific entropy, specific capacity, and you should know what's the definition of the word specific in science. Meaning, there's a gram or a mass, any kind of units in the denominator. You get the point? Just like adding molar, there's a mole in the denominator. So that it's very easy for you to play around during calculations, conversion. Oh, cancel na yun. Ganun. Di ba malipay din ka if there's cancellation somewhere along the way? So to those who can relate in engineering, if there's cancelable, oh, because it's already simplified. You're very, very happy to avoid the complications of your units, compatibility of units of the measurements. Okay, ganon. Oh, di ba? Nakakaloka. Okay, now we go to the law of definite proportion, number 4. So I'm talking to the different laws in general chemistry. Okay, number 4 is LDP. This is not Laban Demokratikong Pilipino, LDP, but this is law of definite proportion. This is not a political term, but this is, okay, law of definite proportion. Okay, discovered by Mr. Jules Louis Prost in 1794. Okay, Jules, okay, Louis Prost. Prost is P-R-O-U-S-T in 1794. Okay, and then based on his experiment, he tried to decompose the copper nitrate, and then this copper nitrate will yield carbon, nitrogen, and oxygen. So that's the time he formulated the laws that states always a compound consists of similar proportions of elements by mass. That is the law of definite proportion. Okay, a compound, okay, right, that, maklaro ninyo guys ako mga suwat-suwat, yes, a compound will always consist, a compound always, take the word always, ha? Meaning consistently, okay, a compound always consists, okay, consist. This is a noun and verb agreement, right, in English. Always consist, okay? This is in particular in the verb and noun agreement. A compound always consists of similar proportions, okay, like that. Wow, nakakaloka. Similar proportions of elements, okay, by mass. To take note, by mass, not by volume. So meaning to say, percentage by mass or mass percent. Okay? Like that. Okay, so if you talk with a yield, for example, percentage yield. We have actual yield over the theoretical yield times 100. So your actual yield is basing on the masses, not on the volume. Okay? Like that. If you divide all mass, there's no unit at all, right? And then multiply by 100, it will become a percent. Okay, so you use mass, not the volume, in this theory. Okay, like that. 1794 by Jules Louis Prost, like that. And then after that law of definite proportion, we have, ikaw pa na law? Yes. The last law is we know the law of the multiple proportion, LMP. Okay, laban ng mga Marcos sa mga Pilipino. No, it's not like that, but this is law of multiple proportions. Okay? What is that all about? Okay, let's erase this one. You already take down this theories and principles or concepts in a blank sheet of paper. If you're listening, then it's fine. If not, you can write like that. Okay? Now, we go to the LMP. LMP, laban ng mga Marcos sa mga Pilipino. Ganon. So, LMP, law of multiple proportions. Okay, what's that it says? Okay, number 4, low or I will just say LMP to make it easy. Acronym or abbreviation. Okay. LMP. Okay. This is all about the ratio of masses. Okay. Take note, masses. So a lot, right? The ratio of masses of the second element. Wow, why like this? Second element talaga siya. Okay. Second element. Okay. So or we can say that in another version. Okay. Actually, there's a lot of versions if you will just understand, okay? So if you add the elements to produce a compound, and then that is really the sum of the ratio of the masses of the second element of each fixed mass of the first element will always be equal to a small whole ratio. It's very difficult to understand the wordings or the statements that when you solve the problem, you can determine what it means. Okay? Solving, for example, gram to mole. Okay? Mole to volume, then going to reverse, volume to gram, and like this, chuba chuchu. So through this, having your stoichiometric balance, chemical equations, chemical reactions, then you can compute from gram to mole, from mole to blah blah blah, so on, so the rest. Okay, and then you reverse that also you can do, and you have your basis of calculation, and you can compute something like that. Okay, you get the point. So I will put the statements or not. You are listening, right? Okay, I will just put. Okay, okay. The sum of two elements. The sum of two elements. Nakakaloka. To produce a compound. To produce a compound. Okay, mga palangga. Okay. Is the sum of the ratio of masses. Sum of the ratio of masses in the second element. Okay. Second element of each of fixed mass. Of fixed mass of other element, okay, is equal to the small whole ratio. Small whole ratio meaning that is a fraction, and the answer will be from 1 to 2, 3. There's no point something here. And the small also, for example, if you divide up two things, your fraction will always be equal to 1, the better compared to the 2, because small, okay, small whole ratio. If not, this will be, okay, this 1, after dividing the numerator and denominator through your let's say, fractions, what can I say for this? If you try to, for example, 1 mole of hydrogen gas plus 1 mole of oxygen gas will yield 2 moles of water, like that, and you need to establish the relationship of the moles. Then if you try to establish the ratio, okay, if you obtain 1 is better than you obtain 2. You'll use the 1 because small whole ratio man siya. You get the point? Muna siya yung hitabo. Or, you need to use this as your basis to obtain your limiting reactant. So, we have also limiting reactant and the exist reactant. Be careful because if you will use the exist reactant to compute to what is being asked in the problem, you will become wrong. So, you will use always the limiting reactant basing to this small whole ratio. This is all about law of multiple proportions na. You get the point? Yung anak siya, guys. Okay? So there's a lot of problems like this. And you have to determine, because the reactants are 2 elements, right? The 2 elements sometimes have given the mass, the other one's given also the mass, and you need to compute individually the number of moles, and then you will relate that to the number of moles in your stoichiometric chemical reactions. Then if you divide the fraction, that what will yield, the smallest one you will be used, not the highest. That's what it means for law of multiple proportion. Oh, ganon. So, we have 4 laws na siya. Okay? Now, so these all are governed, governed from the term equilibrium. Equilibrium, okay? Meaning equilibrium or the dynamic equilibrium. Okay, these things. So dynamic equilibrium. Meaning to say, guys, if you have a chemical reaction, guys, this is the point where your concentrations of the reactants and the products will no longer change. Okay, it stops changing. So the dynamic equilibrium or the equilibrium has been achieved. So meaning to say, the rate of your forward reaction will be equal to your rate of your backward reaction. That's why you can compute for the equilibrium constant based on the expression of the concentrations of the products and the reactants. After knowing that your chemical equations and chemical reactions have been totally and completely balanced. Completely balanced. Wrong grammar. Okay? Get the point? Muna siya ikabuo mga. Any questions so far? Nothing else? Oo, nakakaloka, diba? Muna siya ikabuo mga. Okay. Di ba klaro? Okay. Now, I'll be introducing problem solving na ha on the next vlog. Okay, like this. Okay, mga palangga. The confusing part only based in the expression of the concentration is the normality ha. The gram equivalent, the equivalent like this, because it talks about dissociation. Okay, now the colligative properties, the only confusing part is the Van Hoff factor also. Van Hoff, like that. And then if you are talking about the electrochemistry, it's also the number of moles in your balance equation. When you use the, for example guys, when you use the Faraday constant, right? So Faraday constant is equal to 96,500, like that, okay? Coulomb, mole, Kelvin. So this word Coulomb. So this is a Faraday constant driven by the electric charge constant of Mr. Coulomb, scientist. Okay, so we relate this through the constant of Coulomb, which is 607 times 10 to the 19 Coulomb. Okay, and this is equal to 1 electric charge. Okay, and after that, you can compute for the current after this. So current is equal to this column, the charge, electric charge, over the second or the time. So your unit will be now coulomb per second equal also to ampere. Okay? This in relation to electricity already. Okay? You get the point. So basically this is all about related to electricity because we are talking about electrochemistry, the combination of chemistry and electricity, or should we say the process of producing electricity by using chemical reactions. That is electrochemistry. Okay, and then if we have also another topic, separate topic talks about thermochemistry, a combination of chemistry and thermodynamics, meaning producing heat energy by using a lot of chemical reactions. That is thermochemistry. Electrochemistry, like that. Okay? You get the point. So that's also a separate and special topic in general chemistry lecture. Some will not try to discuss that one because it's related to other topics, but it's better to discuss that separately so that the students can understand really what's going on in that particular topic. Especially very important really guys in semiconductors industry, how to alloy one element over the other, like that, the zinc to copper to produce this, especially the materials of construction of your laptop. Your laptop is made of what element? Oh, let's say zinc, copper, aluminum, platinum, or whatever. So how do you know that? So you should learn electrochemistry topic. Okay, the topics of metalloids, like that, semiconductors, and it's in there discussed very well. Okay, you get the point. Okay, but I am very pretty sure the materials of construction of an airplane is a platinum. Okay. Okay, platinum. So a platinum has an atomic mass of 195.048 grams per atom. Okay? That's the atomic mass of a platinum. And I think there's a lot of lectures also with other metals. You alloy that to other metals. Alloy meaning you try to combine, chemically combine with other metals to produce the desired product or desired metal that you wanted to. Just like for example the galvanized iron sheet. Before attaining that one, there's a zinc, there's a copper like that, and you add that one, that's alloying. Okay? Now we have the galvanized iron sheet. Ganon. Metallic sheet. So those are examples of alloying. Ganon. Of different metals. Okay. What else? Mga palangga, kulitan. Oh, wala na, diba? Okay, it's about time to do the problem solving later on. Okay, guys, if you understand this vloggers, you can comment, you can share, you can like if you want to, and you can subscribe also my YouTube channel if you are not subscribing, and then you can click the notification bell for some newest updates of I am a singer eternal voice by the Lord. Everybody, see you from my next vlog. Ganon. God bless po. Have a beautiful Friday. Charot. Nakakaloka. Diba? Nakakaloka.